Streams are another type of implicit sequence. They are like a linked list, which we looked at earlier in the course, but the rest of the list is computed lazily, on demand, only as needed. As opposed to a linked list, which we represented entirely explicitly in memory, a stream only represents the first element, but it also has a function that allows us to compute the rest of the stream if we ever need it. This form of lazy computation of a sequence allows us to represent new sorts of things that we couldn't before, even including infinite sequences. A stream is a class in Python that we're about to develop. It's also a concept, and the concept is that a stream is a lazy linked list. So it's a linked list in that it has a first and a rest, but the rest isn't represented explicitly. It's only implicit. So a stream is a linked list, but the rest of the list is computed on demand, whenever anyone asks for it. So think of building a link as passing in some first element, and then a second element, which has to either be a link instance itself or link.empty. That's how you build a linked list. A stream similarly can have a first element that's anything, and then the rest is actually not a stream itself, but instead it's a function. The second element is a zero-argument function that returns a stream, or stream.empty. The power of using a function here instead of an instance is that that function can perform some computation. So when you actually want to know what's the rest of a stream, you have to call that function, and the work actually happens to figure out what the rest of the stream is. Once created, streams and links can be used interchangeably. You just ask for their first and their rest. So a stream is actually just a drop-in replacement for a linked list, but it's more flexible because of its lazy computation. Here I have a file called stream.py with the link class, which is review. Here's a simplified version that doesn't contain some of the features that we had before, but just has the core functionality. You have a first and a rest of the linked list. And then down here is a stream. Let's look at the difference. So if I make a linked list out of 1, 2, and link.empty, I can ask for the first element. I can ask for the rest. I can even ask for the first element of the rest of the list. And I'll get the number 2. Similarly, I can create a stream. We'll call that st, is a stream that starts with 1. But instead of having a stream that starts with 2 as the second element, instead I create a function. A function that returns a stream that starts with 2. And the rest of that is a function that returns stream.empty. Now st works in the same way as s. The first element is 1, the rest is a stream that starts with 2. Just like this used to be a link that started with 2. So if I get st.rest.first, I'll get that 2. Now we do see a difference in their representation. The linked list s.rest knows that it ended right after the 2. The stream actually doesn't know whether it's over or not. No one's ever asked for anything beyond the rest, and so it has yet to compute whether there's a rest of this stream or not. Now if we look at the implementation, we can see that when somebody asks for the rest of the stream, it's going to be empty. But since nobody's asked for it, we haven't seen it yet. Okay, so the first thing you should take away here is that these things are interchangeable. But the next thing we need to discover is what are the differences. So let's say we create a linked list that starts with 1, and the second element is 1 divided by 0. Right away, we're going to get a division by 0 error, because linked lists are represented explicitly by the computer. So it needs to compute all of the elements before it can ever bind S to something. But streams are different. The stream that begins with 1 and is followed by a stream that contains the result of dividing 1 by 0 doesn't have an error. You can even get the first element, and it's 1. Now, why is there no error? It's because we haven't actually computed the rest of the list, because no one's ever asked for it. But now, if we ask for the rest of the list, it will attempt to compute that, try to compute the value of 1 divided by 0, and raise a division by 0 error. So we see, quite explicitly, that lazy computation delays error conditions because they don't arise until you try to do the work that involves computing the erroneous value. So we've seen why streams are different than linked lists. But why might they be better? Well, let's look at an example. I'd like to create a sequence of all the integers. Now, there are infinitely many integers. That's hard to put in a linked list because we would run out of memory. But we can put a representation of all integers into a stream. So an integer stream is a stream of consecutive integers. And the integer stream starts with the first element and is constructed from the first and a function called computeRest that returns the integer stream starting at first plus 1. What does that mean? Well, what it means is that a stream has a first value and then some method for computing the rest of the stream. And all you really need to define when you're building a stream is how to compute the next value from the current value. If such a relationship exists, then you've built your stream. Here's the actual code that defines this. I'm going to write a function that creates an integer stream, which will be an instance of the stream class. Its first element will be 1. The rest will be 2, 3, 4, 5, 6, 7, 8 forever, but only so much as somebody asks for. Okay, so for example, we could create an integer stream starting at 3. 3 would be the first element. 4 would be the second element. Even though it's representing an infinite sequence, nothing has taken forever to run. The definition says, if you want to compute the rest of the stream, you're going to return the integer stream that starts at first plus 1. Then, what we actually construct is a stream that starts with the first element, 1 by default, but it could be 3. And then, when somebody asks for the rest, we're going to call this 0 argument function called computeRest in order to compute the rest of the stream, which we'll call integer stream, which will return a stream, but starting at first plus 1 instead of first. Let's try it out. Def integer stream, which starts with some first value. The first thing it does is define a computeRest 0 argument function, which returns an integer stream starting at first plus 1. Now that we have this function which computes the rest of the stream, we can build the stream from its first element and the function that computes the rest. Now to finish our implementation, we just need to import the stream class itself and a function called firstk. Firstk prints out the first k elements of a stream as a list. So let's say ints is an integer stream starting at the number 1. Ints.first is 1, ints.rest.first is 2, ints.rest.rest.first is 3. What about the next one? That's 4. And the next one is 5. If I ask for the first k elements of inst, for 10 of them, I'll see that it goes all the way up to 10. Or I could ask for 100 or 1,000. Now this stream of integers is infinite, but it only computes as many as I ask for. And that's the power of streams, is that they can represent a sequence implicitly, give you access to all of the elements, but only the elements that you actually need are computed.